So thanks for tuning in today. I got to repeat myself. Today's DevSecOps live episode is about the essential DevSecOps controls in Azure that you can get started with today. And what we mean by that is the controls that we're going to show you today are mostly native. They belong to Azure Cloud offering. Some of them are going to be open source controls that we're going to be bringing in Azure DevOps and the Azure portal, which means the Azure cloud itself. And if you feel that your hands are itchy right after this webinar, you could go ahead and try these tools in your Azure environments today. So let's get started. So the slide is, the presentation deck is mostly about 8 to 9 slides. They just have some titles and pictures because we're going to be spending most of the time in the Azure DevOps portal and the Azure portal, where we will be testing some code, deploying some resources, and trying to ensure that if they meet security requirements or not. So for people that are new to Azure, I'm not sure if we can do necessary justice by actually doing a one-on-one session, but what I'm going to do instead is try talking about what an Azure tenant is, and from there talk about, hey, how subscriptions are organized in tenants and resource groups and so on. And from there, we will talk about some ideas about how you can separate your test and production environments and deployment integration environments, because a lot of compliance requirements requires you to do that. And when you're building your software, whether it's your infrastructure as code or your JavaScript or the code for your software, what are some of the tools that you can use during the build stages? We'll talk about that. And when you're in the deployment stages after your software or your web application is deployed, what are some of the tools that you can use? And what we will also do is look at inbuilt capabilities of Azure, like the Azure Security Monitor and Azure Advisor, to see how those free offerings could provide us the necessary insights as people that are involved in securing our Azure deployments, and then see how that's all going to pan out. So first things first, everything in Azure, for example, at the bottom of this slide, you see virtual machines, right? That's one type of resource in Azure. You see apps, for example, web application is one type of resource. Function apps is one type of resource. Your containers and your container registry is a type of resource. And all of these resources do not exist in isolation. You need to have a resource group that contains these resources. So any resource that you would want to create in Azure, you need to put them inside a resource group. Now, that's a mandatory requirement in Azure. And if you want to have the capabilities to create resources and resource groups, then you need something called a subscription. If you go sign up in Azure today by adding your credit card, there's 2 things that will be created for you by default. Number 1 is the tenant, and number 2 is a subscription. A tenant normally relates to a company that can have some kind of contract with Azure, and a subsidiary that can have some kind of contact with Azure. So that is going to be a tenant. A tenant is represented in terms of a GUID, a globally unique identifier. We'll see some of that in the upcoming, we'll see some of that in the demonstrations. And inside those tenants, your credit card is actually bound to a subscription. So you can have one subscription or multiple subscriptions. If you pay by your credit card, that's called pay-as-you-go subscription. But if you contact Azure through enterprise agreements, or if you contact Azure through third-party vendors, cloud service providers, then you can have a subscription as well. So your company is most probably going to have one tenant to manage all your Azure resources. And within that tenant, you can have multiple subscriptions. And inside each subscription, you're going to have resource groups, and within those is where your virtual machines and functional resources, containers, and everything else that is going to exist. Now, first and foremost, the first security thing that we're going to see from a security perspective is there's something called a management group, right? So a management group is the top level resource. It exists inside your tenant. If I go back to the previous slide, the tenant contains a management group. And between those subscriptions, there's something called management group that is not here in the Azure 101 slide, but it is here in the second slide where we're talking about segregating subscriptions. So we start with a management group in this example called corporate IT, right? And the management group can further be divided into your production subscriptions or your development subscriptions or your QA subscriptions. So that way you have your environments isolated so they're not interacting with each other. And within those production subscriptions, you can have your within those production management group, you can have your mission critical applications in a separate subscription. You can have your protected data in a separate subscription and so on. So those are different ways of segregating resources in Azure. Now, in our experience working with customers, if you're a small, medium enterprise, you're probably going to have one management group under your tenant. And because of the fact that you cannot afford to purchase multiple subscriptions to manage your billing, you're probably going to have one management group called the root management group. And within those root management group, you're going to have development subscription, production subscription, testing subscription, and so on. And this makes sense because you can give full access, full unfettered access for developers to your development subscriptions because it's very limited, because you're going to have your development data in there. But production subscriptions, your RBAC roles, your role-based access controls for the same users, they're going to be different in production. They're not going to have direct access to production resources because maybe it's just not needed. So that way, whether you're organizing your subscriptions as dev, test, and prod, or whether you have your management groups, which is one level higher in the hierarchy, if you split your production management group, development management group, there's pros and cons of these approaches. For example, if you have an Azure policy that says developers cannot create virtual machines apart from North Europe region, you're only allowed to create virtual machines in Northern Europe region. You're not allowed to create virtual machines in any other region. If there's a policy like that that exists in your Azure subscription or management group, and if you are a subscription owner, you can go ahead and disable those policies. So sometimes it makes sense to segregate management groups as production, development, and QA. But sometimes it also makes, depending on the size of your company, it also makes sense to segregate your subscriptions into mission critical or dev, test, and prod. Now, within those subscriptions, you're going to have different applications which are going to be present inside resource groups. So that's first and foremost, irrespective of what you do, whether you're in a new state of migrating your resources to Azure, or whether you have a well-oiled machine producing resources through infrastructure as code or PowerShell in Azure, all of those things, take a look at your subscriptions first and split your subscriptions accordingly within a root management group or within separate management groups such as production, dev, and QA, whatever that makes sense in your environment. This is the first step in securing your Azure resources that are deployed in Azure. So that's the first step that we're going to see. And it makes sense, like we said before, you can control role-based access controls for individual subscriptions. And you can also manage costs per subscriptions and say, my development resources, even though some of them can be ephemeral in nature, temporary, some of the resources, some virtual machines can exist for 6 hours. Only, they're automatically provisioned by your Azure DevOps. And then once you're testing, your functional test cases are done, those resources will then be deleted, or your resources will get deleted by end of the day. Now, even in those situations, you want to manage your costs effectively, and splitting your subscriptions help you manage costs effectively. And like I said before, a lot of these compliance requirements, such as PCI DSS or HIPAA or ISO 27001, and all of these requirements require you to segregate your dev, test, and production environment. So that's the first step that you start with there. And you can also apply security controls per different subscription. So that's the first thing I would say. And the second thing that we want to see, this is where we're going to jump into Azure Portal and start demonstration. The second thing that we're going to see today is software component analysis with an example of White Source Bolt. Now, White Source Bolt is not a tool that is from Azure, but it is integrated with Azure DevOps very easily. So within a couple of clicks, you can use a third-party tool such as White Source Bolt. Bolt is a free offering for Azure DevOps from White Source, the company that specializes in software component or software composition analysis. We're going to see a demonstration of that. And then from a static application security testing perspective, we have infrastructure as code templates. In Azure, they're called Azure Resource Manager templates. That's one way of natively using Azure's capabilities of deploying resources, such as virtual machines, function apps, web apps, databases, Ubuntu servers, and whatnot. So we're going to look at some Azure Resource Manager templates and then see if there's any tools that are natively available at Azure or from Azure Security community to see if there's any static analysis that we can do from an Azure Resource Manager perspective. And you can also bring in Ansible, Puppet, and other tools into Azure. We're not going to talk about them today because that's our focus today is to cover only the native tools with an exception of White Source Bolt and OWASP Z-Attack proxy for dynamic application security testing from an application perspective. Now, when it comes to dynamic analysis of the resources that you're deploying through code from your Azure DevOps, after these resources are deployed, you're going to want to make sure that these resources have necessary security built into them. For example, if you're deploying a virtual machine that you need as a part of your Azure DevOps deployment, you want to make sure that you don't have a public IP address with a network security group rule that allows incoming connections through the internet. And that's one security principle that one security practice that you can verify by running security verification tests across the resources that are deployed through the scripts from your Azure DevOps. And from an application side of things, we'll see an example of how you can integrate a OWASP Z-Attack proxy. And then the other thing that we're going to see, another native capability of Azure is secrets management. In Azure, this is called Azure Key Vault. We're going to see how we can store secrets in Key Vault and dynamically retrieve secrets from Key Vault so that we don't have to hard code credentials in our source code repositories. And we're going to take a look at Azure Policies, which is also a dynamic runtime protection mechanism, sort of. So policies allow you to restrict or allow creation of resources and condition those resources to have certain amount of security controls inside them. And then we're going to look at Azure Security Center. So that's what's in store for us today. We will get started by looking at software component analysis with White Source Bolt. What I have here in my Firefox is a lot of different tabs, but we will go to Azure DevOps first. So that's Azure DevOps. And there's a bunch of repositories here. So we'll try and pick the first repository here. So My Fantasy is the name of the repository that we're going to be playing with. Again, the pipelines that I'm going to be demonstrating today, those pipelines are broken down to specifically run White Source Bolt. And those pipelines are specifically broken down to run static analysis on Azure Resource Manager templates, such as the ones that you see here. And these pipelines are broken down specifically to deploy a specific resource, meaning there is no unified pipeline today that, when triggered, is going to execute a bunch of build tasks, execute a bunch of deployment tasks. We're not going to do that today in the interest of time because we're going to see live demonstration. So first things first, White Source Bolt. Let's see where that is integrated. So from a sample demonstration setup perspective, there's some tools here. The source code is organized into the ARM templates are placed into an ARM template folder. There's resources, there's infrastructure as code, Azure's way of deploying ARM templates. As you can see, there's a hard-coded password there for Azure user. There's also templates to deploy SQL servers, and there's also templates to deploy resources specifically to North Europe regions. And then from a .NET perspective, there's WebGoat project, one of the vulnerable applications that we were able to pull. And we're going to be using this WebGoat project to play around and do some static analysis or software component analysis inside it. As an example, for Java, we also got another vulnerable product from Java called the Juice Shop, which is one of the famous products used during security trainings. OS Juice Shop is another vulnerable application. Now, from a pipeline perspective, right, there's a bunch of pipelines that is already created for us. What I'm going to do is try and edit these pipelines to see how they behave. So the first pipeline or the first demonstration that we're going to see is software component analysis. And why software component analysis? Simply because software code these days consumes a lot of third-party libraries that aid in developer productivity. Third-party libraries help us going into production at a faster pace, but third-party libraries also bring in a lot of vulnerabilities into our application source code. From an attack surface reduction perspective, if you're aware of vulnerabilities that are in your third-party libraries, of course, it makes sense there as a quick security win. I see a question after this demonstration. I will take that question now. From a pipeline perspective, here's the pipeline. Let me minimize some windows here. So what I'm going to do is pick that pipeline there and then hit edit on that pipeline. Right, I'm going to edit that pipeline and show you guys what's inside it. So there's two scripts inside it. And if you're not familiar with Azure, if you're looking at the first stage, there's two ways of creating pipelines in Azure. One using the YAML syntax and two using a graphical user interface. In order to make things simple and easy for a lot of us, I'm just going to use the Azure graphical user interface to build and manage these pipelines. So there's a PowerShell script here. What does that PowerShell script do? Well, it does nothing. It just writes a couple of things using PowerShell. We might as well go ahead and disable that selected task because we're not going to need it. The second thing, the second task on that job, on the job that runs on this agent is white source bolt, and you can configure the working directory. For example, white source bolt requires you to provide you the location of the source code that it can analyze for third-party dependencies, security vulnerabilities. And that's the one important input that you're going to have to provide for white source bolt. So what we have done here is went ahead and chosen the .NET WebGoat directory as an input for white source bolt to be scanned. And that is the only thing that you require to provide. What I'm going to do is simply save this in queue. Again, I can go to the trigger option and enable continuous integration on this. If I go by the default options here, every time I make a change to my code repository here, this pipeline is going to be triggered automatically, but I'm not going to do that because I want to run things manually right now. So I'm just going to save and run this build on a default agent pool that is available for us. Save and run white source bolt for software component analysis. The build is queued right now. It's going to take a couple of minutes to come back. But until that time, what we're going to do is look at the steps that is required to set up white source bolt, right? So if you go to pipelines there, and again, if you go inside that pipeline and go into the edit mode, and the pipeline is running, one of the build is in progress right now. And if you hit adding tasks to an agent job, and if you search for white source bolt, that's an extension that shows up here on my Azure DevOps because it is something that I've already added. Now, if you have not done this, White Source Bolt would show up here with a get it free option. Now there's a reason that I got two White Source Bolt here. You know, this White Source Bolt that is already installed onto my Azure DevOps environment is a pretty older version, but White Source Bolt also released a newer version with some minor changes. So that's also something that we can get it for free right now. And if I click that, it's going to take me to the Azure Marketplace, and then I can hit get it free. And then it's going to show me, hey, do you want to install it for your tenant in this specific Azure DevOps environment? And that's the way the installation procedure goes. Now, as you see here, that's the Azure DevOps organization. I can install it, and then White Source Bolt will then be available in my Azure DevOps environment. So it's already added now. I'm going to close this, right, and give this a refresh right now. So it says White Source Bolt is already installed. I don't have to get it for free because it's already installed, right? With that installation steps, let's go into pipelines, click on that task, and check the progress to see where we are. So if you click the White Source Bolt option there, we're waiting for the logs to load. Okay, the logs should show up on the right, and I'm not sure what's happening right now. So we'll just have to be patient. I'm going to do a Command R to hard refresh my browser. Go back here. Okay, apparently we now have the logs, and if I hit White Source Bolt, right, I'm expected to see some logs here, and I don't. Okay, so apparently White Source Bolt, the scan we have integrated is completed, and there's a post-checkout job that takes a little bit of time. So what I'm going to do in the interest of time is click on that agent job and try and cancel it. Right, so that's also complete. We're finalizing the job and build status. Okay, so now we have White Source Bolt logs. So data is being uploaded, and what that means is data is being uploaded to the inventory of the report to be loaded. As you see, the working directory is the .NET Web Code project that we supplied as input, and then we scanned all supported source code extensions. So after this is done, if we go back to pipelines, let me start from the beginning. If we go back to pipelines, and if I hit that pipeline and go inside it, there's a White Source Bolt option right up top, right? And then this is going to take some time to load, and then it's going to show me. Oops, apparently there's some problem there. Let me try the White Source Bolt option here. Okay, so right here, White Source Bolt also adds another option right here. And if you see, we now got medium vulnerabilities to update vulnerabilities, and there's a licensing issue, the typical issues that you would see on the software component analysis and other things. Now, there's also another option. White Source Bolt is one of the first options that was introduced in Azure, and that's why we chose to show that. White Source Bolt supports multiple languages and different software frameworks. So it's a great tool. And it also comes for free. There's also options that allow you to categorize the vulnerabilities and do false positive analysis on the full-fledged version. But if you're using the free version, it is good enough for you to export these reports, right? Now, there's another part of setup that is involved. The first time you hit pipelines, the first time you go there and add the White Source Bolt option into your pipelines, White Source Bolt is going to show up here on your pipeline section, but you're not going to see this report. The report shows up here because I just performed a scan, but if the report does not show up, there will be an option, instructions for you to click and register into White Source Bolt by providing a free email address, by providing your email address. That's the only thing that is needed for you to set up and configure. All right, I'm going to pause the session right now and take a look at any questions that are there. So let's say there's some chat. Okay, did see some questions, but I don't see them anymore. What I'm going to do is continue with the rest of the presentation. So we're going to wrap the chapter on chapter component analysis. If you're in Azure DevOps, White Source Build is a great tool to check out. There's also Sneak, which is also an emerging great tool to check out. What we're going to do now is shift gears and look at some of the Azure Resource Manager templates. And what we're going to do there is go back to our repositories and check out the files and drill down Azure Resource Manager templates. Now here we have an Azure Resource Manager template, and there's a parameter file. Now Azure Resource Manager templates come in two types. Now one, there's a file which is called a template, right? As it says, it's a template that tells you this is the resource group that I need this resource to be published at, and this is the network security policy that I need for this particular resource. This is the particular VNet that this resource should be inside, and this is the subnet configuration and all the other things. They're specified in the Azure Resource Manager template. The template file is often accompanied by a parameters files as well. The parameter file shows things like, hey, the username, the user ID, and the subnet value, and the virtual net value that we can parameterize Azure parameter files, and then tells issues that is found in the Azure Resource Manager template files. So without further ado, let's go back to our pipeline section. Now there's a pipeline that I've already created specifically for this purpose. I was going to go ahead and try editing that pipeline to show how to include ARM template checker, right? And if you don't see ARM template checker, again, you got to hit the plus option there. Then if you search for AZSK, you're going to see the Secure DevOps Kit CI/CD extensions for Azure that is installed on the Azure DevOps environment. If it's not installed, you're going to see the get it for free option. And once that is done, you're going to see the ARM template checker option, and you can add that or drag and drop that into your Azure pipelines right there. But what I've done is I've already done that, right? And there's two basic things that is required. Like the static analysis tools requires you to upload the source code in order to perform static analysis on them. So here we require basic information in terms of, hey, this is the template file that I'm using in today's deployment, and this is the parameters file that I'm using. You can either specify a direct file, a direct template file, or you can specify an entire directory. You can also use the triple dot option there to browse and choose an entire ARM directory so that all the template files will be picked out from that directory. But for now, all right, let's keep it as is. And then for the parameter files, since they're also updated in the ARM directory, I'm just going to choose the top level ARM directory because all my templates and all my parameters that correspond to those ARM templates are present in this particular directory. Now with that, I'm just going to save and queue and look at that agent job and wait for it to complete. The AZSK utils that we have already installed, comes with two different tools that are present in Azure. Number one is the ARM template checker, which is what we're seeing right now. We're waiting for it to run. And number two is the security verification tests that we're going to be looking at later. So let's wait for ARM template checker to evaluate all our ARM template files, and then see what kind of security recommendations that it provides. Shouldn't take more than a minute or two. We will wait for this to complete. Well, if you have any questions in the meantime on the subjects that we've covered so far, feel free to post them on the chat or the Q&A section, and we'll talk about them. What we can also do is go back and explore this pipeline's history and analyze the previous files. So on this agent job, when the ARM template checker ran before, it detected that we have not configured IP forwarding for the NIC card. So that's one security finding that it detected. And then if we look at the other run, the run that came before this. All right, let's go back to pipeline again. ARM template checker. Well, apparently our last run completed 2 minutes ago. We were waiting for this job to complete. So let's see this. Okay, one or more files were skipped during the scan. Either they were not ARM templates. Okay, great. So what this means is, under our directory, we got some files under our directory, ARM templates. Now, under this directory, we got some new file 1, and they're not valid ARM templates, so they're skipped. But for the rest of the files that are not skipped, let's look at the results from the beginning. So here's ARM template checker starting analysis on the SQL database template file, right? And then there's a lot of controls that apparently failed here. For example, the app service endpoint does not allow headers. Now let's look at the SQL specific audits. Threat protection is not enabled. And then SQL database auth authorization uses Azure AD admin. We'll look at some other errors as well. So these are the parameter files that were apparently not detected, so they were skipped. What we can also do is try, instead of giving the entire directory onto the ARM template checker, we can also try providing the direct file name for a specific SQL database or Ubuntu parameters. For example, let's look at that Ubuntu template, the ARM template that will create the Ubuntu file. And then we will provide the parameters file, save and queue the build. And then we can also observe these results there. Now that's one of the things from an infrastructure as code perspective. You can use the ARM template checker to statically verify your ARM template files. Now, there's many ways to deploy resources in Azure, right? The native way of doing that is by using ARM template files, which is also recommended by Microsoft. But having said that, there's also Terraform way of deploying files in Azure, deploying resources in Azure. There's also PowerShell ways of deploying resources in Azure. And there's also Chef ways of deploying resources in Azure. There's multiple infrastructure as code tools that you can integrate with Azure DevOps. So just like we're deploying resources through ARM templates, you can also deploy them using Terraform and PowerShell templates, or PowerShell desired state configuration for that matter. Now, there may be security tools. For example, there's Terraform security tools that will allow you to statically analyze your infrastructure as code files. You can take advantage of those. We don't have demonstrations of those today. There's also PowerShell linters available that will statically check your PowerShell code for code analysis. But if you're using ARM templates for most of your deployments, then ARM template checker is a great way to check your ARM template files and then find out from a Microsoft best practice security perspective if there's high, medium, and low level findings that you need to incorporate. So that's a wrap on static analysis for infrastructure as code. Now, these are things that you can get started with today, like I said before. The third thing that we're going to be talking about today, we're also going to be wrapping static analysis. We're going to be moving into the dynamic analysis section now. There's a couple of ways that development teams deploy resources in Azure. As an example, here we have an Ubuntu server here. What I'm going to do, there's a resource group. It's a hypothetical resource group. It's called My Fantasy 2. I'm just going to delete the resources in here. There's only one Ubuntu server that we've created there for test purposes. I'm just going to delete all of those resources. And then if you have worked with DevOps and engineering teams that are working in Azure, if they're using feature-based branches for development, they're going to have IDs for individual features, or the features are going to be named something, right? The IDs are typically the feature IDs from your issue tracking systems or product backlog management systems. So the typical practice is create these resource groups and call them My Fantasy the ID of the feature that is implemented in Azure. So for every feature that is present in your issue tracking system, such as Azure DevOps boards or Jira or any other issue tracking systems, those IDs are appended to these resource groups. So when we go to Azure, when we go to Azure subscriptions, we can easily identify that this particular resource group contains all the features that are present for this particular new feature that we tried and implemented, right? And all the resources under that resource group correspond to that feature. Now, when you're deploying, oops, there's some error messages there. There's one succeeded delete. Okay, we'll just try and delete these resources again. Okay, now, when you deploy resources via your infrastructure as code, like whether it's PowerShell or Terraform, Azure ARM templates, those resources are going to lie inside this particular resource group, My Fantasy, minus your ID, the ID from your bug tracking systems. So if you want to make sure that all the resources inside that particular resource group follow security best practices according to Azure, well, that's where the security security verification templates come into play. So after your resources are deployed in Azure, then you're going to want to make sure that those resources in Azure follow best practices. And that's the second tool from the Azure DevSecOps kit, which is called security verification tool. The first tool is the ARM template checker, which checks statically your Azure Resource Manager files. And the second tool, which dynamically logs into your Azure subscription and verifies a certain resource group and the resources inside them, well, that is called the security verification test. And in order to do that, we're going to switch gears and move from pipelines, which is Azure building things, to releases. Releases is Azure's way of releasing resources or deploying resources, right? And there's a bunch of resources that exist already. If we have to see these releases in a graphical user interface and sort of visualize how a test development and deploy phases look like, let's just wait for this page to load, and it should give us a graphical representation. Okay, let's go to resources again and try clicking that pipeline and go with editing that pipeline as an option. Let's wait for this page to load. I'm going to do a Command R to give this a hard refresh. Okay, there it goes. So This particular pipeline called version 20 release pipeline for our software has different stages. There's a test stage, development stage, and a deploy Ubuntu stage, because we're explicitly going to be deploying an Ubuntu server there. So if you look at this particular test stage, there's various jobs and tasks inside those stages. We can add as many tasks as we want according to our requirements, but for now, we just have one simple agent and one simple task inside it. And what we're doing here is calling a PowerShell commandlet called AZ resource group deployment. This commandlet is going to help us take the template file, right? Template.json file, along with this parameters file, and then help us deploy this template in Azure Resource Manager, right? Now, as we're deploying these resources in Azure Resource Manager, we're going to be checking for vulnerabilities inside them. So we'll go back and look at the development as well and see what's inside it. So this particular test case has a very specific task called AZ-SVT. Again, if this is not available, you can get that from AZ. You can get that. You can get this particular task by typing SVTs. So this is one of the unit test converter. If you want to convert all the results from AZSK into NUnit format, you can use this particular job. Because I have AZSVT already added there, it doesn't show up. So if you go look at AZSVT, it requires some mandatory inputs. Number one is a display name, is obvious, and number two is the connection, which determines, go inside this Azure subscription and look at the specific resource group name. And the resource group name that we're going to be scanning today is called for Neverwind, right? And where does this come from? So, all right, let's, again, I think some of the resources failed again, so we'll try deleting them. Again, if you look at the resource groups that are present inside the subscription, there's a resource group called for Neverwind. There's a bunch of different types of resources inside it. There's a database, there's a web app, and there's a function app, and there's an application insights and a storage account and whatnot. Now, all of these are required for an application that is deployed as a test that is called HTTPS neverwind.azurewebsites.net. So this is the sample application that is deployed right here on this resource group. And you need a bunch of web applications and databases, function apps, and other things in order for that application to function. Now, if this is an application that we're continuously deploying using our resource manager here, we can make sure that this is the resource group that we want to validate for security. Now, let's just create a new release. And what we will do is create a new release and go inside that release, trigger a manual deployment on the test stage and wait for that to complete. Let's click logs on there so we go directly to the logs. All right, so we're now waiting for the request to be queued and the job should start momentarily. So if you go to the task section again, you can actually see, okay, this is the only task that we're trying to run here. And if you have variables, you can also determine, you don't have to hard code the resource group name there. Oops, sorry. Let me cancel this. This is the other resource. We don't want to deploy that. We want to deploy the AZ-SVT. So that's what we want to see a demonstration of right now, AZ-SVT. And we want to do security verification tests on the Neverwind group right here, which is present inside our Azure subscription. So we're going to be scanning all of these resources dynamically according to Azure best practices. So if you go to the log section, AZ-SVTs are still pending. Azure is downloading its artifacts, and then AZ-SVT should kick in momentarily. Now, what development teams normally do is instead of hard coding is instead of hard coding that resource group right there, they have a variable that somehow relates to the ID of that particular deployment. If you're following best practices, like we saw before, for Neverwind, it's going to have for Neverwind minus that feature reference, which is Azure DevOps tasks or whatever. So that task is going to be dynamically added here in Azure variables with the $curly braces. So Azure SVTs will run specifically on that branch, on that resource group, which exists for that particular resource, for that particular feature that the development team tried and developed. So let's go check the logs again. We'll give this some time. It's been running for 56, 57, 59 seconds. Let's wait for this. It should complete momentarily. And if you have a lot of resources inside your resource group, it has to spend time and scan each of these resources in order to give you the results. So let's be patient and wait for that scan to complete. Again, while we're waiting for these scans to complete, if there's any questions, we can take them right now, either via chat or through the questions section. All right, seems like this may really take a while. All right, so there we have, for now, AZ SVTs running right now. So it's checking different resources. So checking resource 1 of 3 and says transparent data encryption must be enabled. SQL Server threat detection is a premium feature. And then we'll look at, all right, so those are some of the tests that were run on that particular resource group. Let's just look at these. So there's apparently 15 high, 25 medium checks, and out of them, some of them passed and a lot of them failed. So let's look at each of these things and try to see if there's something that we can make sense of, right? So there's a resource called Neverwind Polar. Oh, I know that's a function app, right? It says authorizations configure IP restrictions so that the function app cannot be called by throughout the internet, through the internet. Maybe we only want to call those apps from a specific IP locations. And then do not allow HTTP access for Neverwind Polar. So you can actually enforce HTTPS on these endpoints. We haven't done that yet, and that's why that error shows up. And then Azure Storage encryption and transit is not enabled for our Azure Storage, so that needs to be enabled as well. And there's a lot of other errors for SQL Server that is present on this particular resource group. So all of these resource groups have been, so if you get inside that particular function app and try looking at the SSL settings, let's say SSL TLS settings, there's an option HTTPS only. And if we switch that option and rerun this test right here, then that option, do not allow HTTP, should go away from there, right? So I'm not going to do that right now because this is a test tab that we've deployed and will be some breaking changes. So there's a question right now. Can you configure the checking rules in AZ SVTs? Right. there's a way in which you can ignore a certain rule, but I'm not aware of any ways that allow you to configure a particular rule right now. This is, again, AZSVT is a tool directly not from the Azure team, but from the Azure consulting team that works with different customers. So they've provided this tool. There's ways where you can say, well, check for this vulnerability, but do not report it. That's something that I'm aware of, but I'm not aware of configuring rules for AZSVTs at this point in time. But thanks for asking that question anyway. Is there a native Azure SCA, SAST, and DAST tool? Well, unfortunately, I'm not aware of any native SCA, SAST, and DAST tool from Azure. So we did look at White Source Bolt, and we did also mention the other SaaS-based option, the software as a service option from Sneak. Depending on the Python language or Java, you can try running OS dependency check and a lot of other tools. Joellen, I'm specifically answering this to you because you happen to be one of our students. Of course, a lot of tools that we teach in our courses can be integrated in Azure through command line interfaces, but those tools are natively not available in Azure. And the same applies for DAST and SAST as well. We're going to be looking at OWASP ZAP as one of the most widely used tools from a DAST perspective, but natively that's not available in Azure yet, right? But having said that, let me try and go to one of these tasks, right? And try edit these tasks. I'll edit these tasks. No, I can't do that here in order for me to show. Let me try and go to these pipelines and try and search for third-party components that are available here in the list of tasks. So if I look up for OWASP, let's see what tools come up here. I'm expecting dependency check should at least show up. All right, so there's a dependency check. Again, it's not natively available from Azure, but it's a third-party tool that's available right here in Azure DevOps that you could try. And the same applies for OWASP Z attack proxy as well. You can try that out here, but we're not going to use these two options today. We're going to be using the native baseline scan option from OWASP Z attack proxy, but there's also other ways that you can try these options. All right, so what else? Maybe what we can do from a live demonstration perspective is I'm going to try switching this HTTPS option, and let's just wait for it, because I know for sure that I'm consuming the HTTPS endpoint here all the time. So we'll wait for that option. Okay, that is apparently switched, right? And what we will do is go back to that particular deployment that we did, right? Let's go back to our releases and pick our last release, that is this development stage, and do a redeployment, right? And let's see if that error on enabling HTTPS only disappears from the Azure SVTs. Now, in fact, I mean, a lot of development teams do not actually know that these security tools exist. Now, we work in the security space as consultants, and we're well aware of these tools because we follow the Azure security community. But when you present these tools to developers, they get pretty excited about these things because they kind of can self-reflect about their security practices that they're using to build and deploy their tools. It's like a mirror that you show to these development teams. They can use these tools and change their production environments or development environments like what I'm doing right here, right? So let's wait for that job to complete. And in the meantime, the next thing that we're going to talk about is Azure Policy and Azure Security Center. I'm going to switch gears and talk about secret management within Azure using Azure Key Vault. I'm going to talk about that in a little bit. But before that, let's go directly into the Azure portal right here, and then talk about Azure policies and some of its use cases and how it fits into. All right, one moment. Let's just type policies. Okay, there's another way of finding that. We're just going to go to home, create resource, or we'll just go all services and then type policies. Okay, so there's policy. So this is Azure policy. And right now there are some policies that are enabled. There's some compliance requirements, 31 non-compliancy and so on. There's Azure security benchmark that I've enabled right now, but you don't need to worry about all of these things at the moment. We will, of course, talk about it when we talk about Azure Security Center and the relationship between Azure Security Center and Azure policies. But for now, once you're in Azure policy, you could directly jump into definitions, right? If you're starting in Azure policy, there's lots of policies here. And there's also some initiatives. Initiatives are nothing but a group of policies. So we're just going to filter this based on policies, right? And what we're going to do, I'm not talking about initiatives right now. We'll talk about initiatives. For now, initiatives are just a group of policies. We'll take a simple policy that we can all understand and try filter these policies by location. I'm just going to pick that policy called allowed locations, right? And I'm going to assign this policy. This is a policy that allows you to restrict the locations your organization can specify to deploy resources, right? Again, this can also be applied through code and PowerShell. I'm just going to demonstrate it via the Azure portal right now. So what we're going to do is assign this policy to our subscription. We can also assign this policy to a management group. Remember management groups that we spoke about earlier? Management groups helps you organize your subscriptions. We're just going to deploy it on, we're just going to test this policy on one of our subscriptions. We can also test it on, we can also enforce this policy on particular resource groups, and we're not going to do that. We're just going to apply this policy at a subscription level for now. So let's just select that subscription, right? And then go to the parameters section and specify North Europe as the only allowed location for any resources that are deployed in this particular Azure subscription. So once that policy is there, we're going to go back to let's down page. We're going to go back to the deployment. So Azure SVTs are still running. All right, so once we have deployed those policies, right now let's not multitask. We will wait for this Azure SVT to run. All right, checking deployment 3 of 3 right now. All right, it failed, but we're interested to see if that service never went polar. Do not allow HTTP access. So when we ran this SVT previously, we did not toggle the setting here. But after we ran SVT, we discovered a new security setting, and then we toggled the HTTPS only, hence that particular security verification test passed. The second time we ran the security verification test after enabling HTTPS only on that function service right there. So that's there. We were dealing with Azure policies, what we just did. So we're right here, allowed locations. So we just assigned this particular policy. And after we have assigned this policy, we can go to assignments, and then there's the allowed locations policies with a parameter value of North Europe right now. So let's go back to Azure DevOps. And what we have here on, if we go to tasks, or let's say we start from releases again, we're going to try and deploy a resource, right? On the test stage, we're going to try and deploy a resource, right? it already failed, and then we'll see how this task was canceled. What we will do is try and redeploy that particular test stage right there. So if you're interested to see what's happening inside that test stage, you can go inside and then check out, hey, we're doing a template deployment. We're doing a template deployment based on Azure Resource Manager. And we're using the template.json and the parameters file parameters.json there. So they're present here. So the template file is right here. It deploys a virtual machine. And if you look at the parameters.json, it's trying to deploy the resource in the East US region. Well, we just declared a policy that will allow deployments only on Northern Europe. So this particular deployment is expected to fail, right? We're waiting for the console output. And because this is not related to ARM templates or anything, this is Azure policies. Even if you try creating a policy, even if you try creating a resource in GUI or whatever means, this particular policy allowed locations will be enforced on any resource deployment on this particular subscription ID, right? So to demonstrate that, we're trying to use Azure resource deployment. So invalid template deployment. Template deployment failed with multiple errors, but that's the error message that you get. You don't get anything beyond that. You could try using the -debug flag to print debug messages. So you will know why this template deployment failed. So what we will do is we got two options here. We can either go back and change this value to North Europe to deploy this location, to deploy this resource in the Northern Europe region, which may help with GDPR requirements. Or what we could do is edit this policy assignment and include East US as, okay, let's just verify that it's East US. Okay, it's East US. So we can also add East US as an additional parameter, review and save this policy assignment. And once that is saved, we will go and redeploy this resource, right? And this resource deployment should succeed because we now have an Azure policy that says the list of allowed locations is North Europe and East US. And according to our parameters file that we're using here to deploy this Azure resource, we're using East US as a location parameter, and East US is in a list of allowed locations. So the deployment should succeed, and we will wait for this to complete. Any questions on Azure policies so far? So while this deployment's going on, we'll also get inside Azure and then try looking at the other policy definitions that are there. So if you go to policies and look at definitions, right? And if you try listing only the policies and not initiatives, I was going to give a quick scroll. There's policies for various resources. You can also categorize them, sort by category right there. If you want to look at policies for web apps or app service, as it is called. So I think I clicked something there. 51 categories. Nope. I just want to look at app service. So if you want to filter policies only for app service, so those are policies that are there only for app service. And then you can enable only those policies for your environments. Let's go back and see. All right, so now if you look at the Azure Resource Manager template, the logs are loading right now, but that job succeeded right there, right? If you looked at the previous attempt that we did, we were trying to deploy to the East US region, which was not in the list of allowed locations that failed. And we're now trying to deploy again to East US region, but only this time, East US region is a part of the allowed locations and that passed. So there's a question, do Azure policies require a specific license? Not that I'm aware of. Azure policies, you can You can use, even if you're using a pay-as-you-go subscription, it is completely free. There is no cost that are involved in using Azure policies. Is there a way to give more information in the error messages? So, oh, there's another user that's asking, is there a way to give more information in the error messages so the DevOps team knows why the policy got rejected, right? Well, there's multiple ways to do that. If you look at this policy attempt, the attempt to deploy this particular Azure resource failed, and it failed just with an error code 1. It just says invalid template deployment. Please see details for more information. Hey, but where's these details? The job that we're using here, the PowerShell command that we're using here, the new AZ resource group deployment doesn't unfortunately provide more details than what we saw here in the logs. But there's different ways of deploying resources in Azure. There's also using an inbuilt. So this is an Azure PowerShell task. We're explicitly calling PowerShell. If you're using the Azure deployment task, it would give you more error messages. And if you try and run this task on debug mode, then that would also try and provide other error messages. So those are some ways that I'm aware of when you're using Azure resource deployment. If the deployment is and if the deployment is rejected for some reason, those are some ways that you can find that out. There's a third way, which is actually by going inside Azure and looking at activity logs. This happens to be the most effective way of finding that for most DevOps teams that I've worked with, right? So look at that denied there. That's most probably the deny option. So let's try looking at the JSON there. So this is how we normally look at these templates. So we try to deploy a virtual machine called my VM, and the validation failed. And if you deep dive into these error messages, the policy failure, so there's a policy definition. Apparently, do we get the policy assignment name? So that's the GUID. And if you drill down, you would actually find out. So that's how DevOps teams actually look inside why this particular deployment failed and so on. I hope that helps, Laura. So if there's any questions, feel free to post them as we go through these demonstrations. But for now, let's go back to this Azure deployment and wrap this demonstration on policies. So that succeeded. So that's one way of using Azure policies. The other way of using policies, as you saw in Azure, that these policy definitions at the end of the day are nothing but JSON. You can actually deploy these policies using code and PowerShell as well. Yeah. There was a reason that I was filtering these policies that I was filtering this view by policies and not looking at initiatives. And these are individual policies for individual resources. If you want to group certain policies that make certain sense for you, then you can group them together as initiatives. So let's try looking at these initiatives, right? And look at that first initiative there, which is under preview, which helps you validate for NIST SP 800 guidelines, and it has 77 policies that will help us validate it. You can also look at the PCI 3.2 version in 2018 as an initiative. And if you look at that initiative, as I mentioned before, initiative is a group of policies, and it has these policies grouped together that will look at various Azure resources, and it will tell you whether your resources are secured against that particular PCI DSS standard or not. And that will also be a matter of simply scoping this policy to a management group and specifying the required parameters for all of these resource types and so on, right? So I'm going to cancel this because there's another feature available in Azure that will help you work with these compliance requirements so you can check whether you're compliant or not. So with Azure policies, there's no licensing costs that are involved. Go ahead and try looking at these policies, filter it based on your resource categories, because I don't think, at least based on my experience, not a lot of development teams use Signal R, or they didn't use everything inside it. So depending on your resource usage, what you're consuming, try checking those policies and enabling some of them. And there's another question from Vincent. Is it advisable to send these pipelines and policy logs to other teams through Slack? Yes, of course. You can send them through Slack. The only thing that you require with Slack integration is an ID that will allow you to push through Slack. It is advisable, provided that your development teams are active on Slack. The other advisable way of doing these results, which I don't have a demonstration of right now, is taking these. All right, let's pick the deployment attempt. Let's pick the previous release that we did, all right, under development. All right, so if you want to see these tests as failures, right, you want to consume these failures as, okay, that's a vulnerability that I need to fix. This is another vulnerability that I need to fix. So I got 10 vulnerabilities that I need to fix. You want to grab these vulnerabilities and put them as in your pull requests. So if you have your pull requests that are integrated to run these tests, so that's a great way to put. You can also integrate these results with your bug tracking systems or Azure DevOps. So those are other advisable ways of working together with DevOps teams. And of course, you can send them on your chat systems as well. But the intention is bringing these issues to the development team and the DevOps team's attention at a place where they collaborate most often. If Azure DevOps is a place they collaborate most often, put them in the Azure boards. Or when a build fails, development teams are normally very cautious looking at the build results. So that's also a greater place. So this being right here is also a great place. I hope that answers that question there. So a quick recap. I'm just going to go to the keynote and see where we are. So we did look at some software component analysis, voice versus bold. We did look at statically analyzing Azure Resource Manager templates. We did look at security verification tests, which will run security verification tests against a specific resource group, focused on a specific resource group. So we did look at that. Secrets management is next in line. We did look at Azure policies. What are policies? Policy initiatives. We looked at a demonstration of that. And then we paused Azure policies by looking at a PCI DSS standard. What we're going to do is look at another Azure offering called Azure Security Center. So it's just going to be Security Center, right? So right there, Security Center. Now, I have already gone ahead and enabled Security Center and some default controls. So that's why you see a lot of recommendations, secure score, and a lot of these results. If you have not enabled Azure Security Center, by default, you will see these options to upgrade or skip. And if you skip the option, by default, you will be placed under the free tier of Azure Security Center. So there's a free tier and there is a pricing tier. So as you see, we now have the free tier on. With the free tier, you get continuous assessment and security recommendation. Azure Security Center is going to continuously scan your resources and give you recommendations as we saw a few seconds ago. And you also get an Azure score. With a premium option, you get all of these other things, threat protection, regulatory compliance dashboards, and so on. What you can also do is scroll down and try these things for 30 days. So after 30 days, you will automatically switch back to the first two offerings there. That's something that you can try. But what you get out of that is things like just-in-time access for virtual machines, regulatory dashboard compliance and results. So that's one of the reasons we paused on the PCI DSS policies before. So if I go to regulatory compliance right now, I have a dashboard that tells me Azure Security Benchmark, 16 controls out of 40 controls are passing. These controls are nothing but policies that are grouped as initiatives, right? The policy grouping initiative that we saw before as Azure PCI DSS 3.1, those policies are actually right here. You can see the compliance of these policies right here. As an example, we now have the Azure security benchmark. So let's just look at this controls. What are these controls and why they're failing? So if you look at network security, there's implement network security for internal traffic, establish private network for Azure services, probably because some services are open for public. If you look at data protection, maybe there's sensitive information, there's data at rest, which is enabled, encryption for data at rest, which is enabled, but some other things are not enabled. And if you quickly expand all controls, there's also quick fix options available for some of these things. I'm just trying to find one of those. So secure transfer of storage accounts. So that's a quick fix right there that you can click. And there's also quick fix remediations for Azure Defender and other things. So this is another great way by enabling security. Now, all you got to do is go to your Azure portal and go to Security Center and enable the free tier by choosing the skip button right there. There's two options that you would see if there's the first time you're seeing Security Center. The first option is upgrade, the second option is skip. If you do the skip option, you would see everything that you're seeing in front of my screen right now. You'll get a secure score, the list of resources that are assessed, and the list of active recommendations that are present for those particular resources as well. So this is something that you can enable for free. And if you want to upgrade, you can also upgrade yourself for the pricing tier. And the pricing for individual resources are present right there on this page. Enabling Security Center on your development subscriptions can have a huge impact on your costs, because sometimes development teams can have up to 1,000 different virtual machines. If you consider small, medium enterprises, 1,000 different virtual machines that are used for development and testing purposes, and that cost can be huge. But if your production servers, virtual machines are less, then that's the cost that you pay. Now, if you're a larger enterprise, then of course the cost is different. You can negotiate the cost with your cloud service provider and so on. So that's a wrap on Azure Security Center. This is a native capability. Azure Security Center and policies are native capabilities available in Azure. The next native capability that we're going to be looking at is the secret management capabilities. I'm also looking at the time, and it went very fast today. We're hitting the deadline for the webinar, but I'm going to continue, right? So what we're going to look at is secrets management, right? So I'll do this really quick. So Key Vault is Azure's way of offering secrets management, right? I've already gone ahead and created a Key Vault right here. If not, you would have to go ahead and hit that create button there and then choose your pricing tier. I've just gone ahead with the standard, which is close to the free option. It's priced very less, right? And if I go to my subscription and show you a cost, that's going to be very less depending on the keys that you use, of course. So once you've created that Key Vault, the immediate next thing is to create secrets and keys. Keys are nothing but your SSH keys, RSA keys, and so on. Secrets are nothing but things like administrator password, which is something that I will be demonstrating right now. And then certificates are nothing but SSH certificates. Access policies allow you to give fine-grained controls in terms of, do I want to give my Azure Resource Manager permission to these Key Vault? What you can also do is add Key Vault policy, and you can actually say, I want to only provide access to key management or secret management. I just want to provide access to secret management so somebody can list, create, and back up those keys and select a particular user there. We're not going to do that. So what we're going to demonstrate right now is go back to our Azure DevOps again. And in Azure DevOps, we have this third deploy Ubuntu pipeline right here. What I'm going to do is create a new release. And the reason that I want to create a new release, or maybe I just want to do a deployment there, or edit pipeline, edit this particular release, go to the tasks section there. What I'm going to do is remove that secure option, right? And if I remove the secure option and schedule this pipeline, this is going to use the Ubuntu ARM parameters.json file. And if I showed you that Ubuntu ARM parameters.json file, the password for the administrator user for this Ubuntu machine, the administrator username is Azure user, and the hard-coded password there is password 123456. Yeah, that's the password that will be used if we deploy. Now that's a hard-coded password. This is one example of hard-coded password present in Azure Resource Manager templates. Your hard-coded password can also be present in your config files in .NET and properties files in Java and whatnot. You might also require passwords while connecting to third-party resources from Azure DevOps. So how do we use Azure Key Vault right here? So let's go back to Key Vault and try creating a new secret, right? Let's just go ahead and create a new secret here. So I'm just going to call this secret as ADMINBWD2. And I'm just going to specify that value, password value, and I can set an activation date and an expiry date for that secret. And once I create that secret's going to be created and it will be expired after a certain period of time. So in order to make least changes and to fast forward this demonstration, I'm not going to use this newly created password, but instead what I'm going to do is go to this existing administrator password and create a new version of this password. So I'm just going to enter a secret, a simple secret, an uppercase A 4 times, uppercase A 4 times, @11. So that's the password that I type. I'm not going to give any expiration dates and so on. I'm just going to create this password. What I'm going to do, go back to this Azure pipeline here, the deployment pipeline, discard these changes, right? Preview the existing pipeline. We're using a secure parameters file. I will show you how we're consuming the secure parameters file while this deployment is in progress. But for now, I'm just going to deploy this Ubuntu resource. Wait for that deployment to complete. We will go to the log section, wait for that deployment to complete. And while that deployment is going on, let's go to the secure version of the ARM templates file. Notice the insecure version has the passwords, but if you look at the secure version of this file, if you scroll down, so that's the way we're referring the key vault right there, the password key vault. So previously, admin password contained a value which directly mentioned the hard-coded password. But for now, we just have a reference to Key Vault with the ID, our subscription name, and the name of the resource group is KV. If I go back to the Key Vault, if I look at the Key Vault, this Key Vault is present in a resource group called KV, and the name of the Key Vault is PDSO KV, and that's what we have provided there. And the name of the secret is administrator password, which is that one, right? By default, it's going to use the newer version of that secret. And once that Ubuntu machine is deployed, we will try logging in as Azure user and try putting in the new password. But fortunately, that failed. The template deployment failed with multiple errors. I'm assuming that this is because of the policy assignment that we did earlier. So I'm just going to quickly go to policies, assignments, and allowed locations and delete that assignment so we can continue with this deployment again. So let's deploy this. I'll wait for that to complete. Again, this is the last part of the demonstration. One of the key capabilities of Azure is secrets management. And a lot of development teams, at least mature development teams that we've seen in our consulting experiences, use Azure Key Vault. If their software development shop is completely in Azure, they use Key Vault. Sometimes we've also seen development shops that use other cloud providers and other repositories, such as GitLab. The repository is in GitLab, but they use Azure DevOps and Azure Key Vault for storing their secrets. So if there's any questions up until this point, feel free to put them in the questions or the chat section right now, and I'll be glad to take those. All right, okay. Unfortunately, there's a problem with our script admin password. It says admin password, cannot find a mandatory parameter admin password. So let's go back to well, there is admin password. I'm not sure what went wrong, so we will try and create a new release and see how that works with the latest change set. Updated Ubuntu on parameters, create. All right, so there's a question. What user is the pipeline logging into Key Vault? I will answer that in a moment, Vincent. So create new release is created, and deploy Ubuntu. Go to the logs, go to tasks. Let's see, all right, we're using the secure version of JSON. It is complete. Okay, so right now, the Azure has a service. Azure DevOps is connected to Azure, for example. The Azure DevOps environment that you're seeing in front of my screen right now is connected to our Azure subscription. If I go to Azure subscriptions, this particular subscription is connected to our Azure DevOps through a service connection, through what is called a service connection. And a service connection internally creates a service principal, and that service principal is what is being used behind the scenes to connect to this Key Vault environment. And on top of that, there's one other thing that you require. That is, if you go to the access policies of this Key Vault, you're going to need to provide Azure Resource Manager template. For that checkbox need to be checked if you're using Resource Manager template. Are there tools available in Azure DevOps to scan reports for hard-coded credentials? There used to be a tool called CredScan. I'm not sure if that exists still. It used to be a free offering, CredScan Azure DevOps, but as far as I remember recently, they moved it to a commercial offering right now. Yep, so that tool was available to scan for credentials for CredScan. It was natively available in Azure, not in Azure, but this is one of the tools that was available as a part of the SecDev tools kit, but it's not available anymore for free. It's deprecate, as you say. It's not available anymore. So otherwise, we got to fall back to tools like TruffleHawk, Secret Scans, and other tools out there. Natively in Azure, I'm not sure anymore. I don't think it's available. So let's go check this pipeline. We'll go back to our releases. Deploy Ubuntu, that succeeded. And then if we go to our My Fantasy 2 resource group, our Ubuntu server should be there. So that's the server that just got deployed. And if you look at the activity logs, we should see logs that's just a minute ago. And again, so the policy action failed before, so that's why the deployment failed. So if you go back to the resource, pick its public IP address there, copy that, and open an SSH prompt right here. Try SSH Azure user, which is the default user, That's right, that particular server. You prompt for credentials, yes for the SSH prompt, uppercase A at the rate 1. That should let us log in. Oops, that's okay. Want to make sure that I type it right. All right, what we will do is go back to the key vault itself and then take the password from there. So key vault secrets, pick administrator password, that, and then show secret value. So that's the secret value there. Okay, so I pasted that into the terminal and we're in as Azure user. And if we do the host name, it should be able to do, which is the server that we're out right there in Azure. All right, so that's it for today, I guess. We're in the end of the chapters. We reviewed a bunch of some of them native, some of the security controls in Azure. There's one demonstration that we couldn't cover today, that is the OSZ attack proxy dynamic scanning, but we'll reserve it for the future sessions on Azure DevOps, where we talk about a lot of other security controls as well. We'll deep dive into Key Vault, look at examples of how application security teams can configure service principals as your users, like Vincent mentioned there. So any questions, feel free to ask them right now. We hit the end of the session. All right, I'm sorry, Jolene, we overran. We hit the time boundary, so we'll cover Z-Attack proxy next time with Azure DevOps. So there's a couple of other questions. Can anyone call the value of the secret from Key Vault using the string, or we can define access? Yes, access can certainly be defined through access policies. And if you go to the networking section, you can also define Key Vault access only within private endpoints or through the internet. Access policies, you can certainly define only certain users or certain service principals based on applications. That is completely customizable. Then your service policy should have access. Yes, that is correct. And there's a lot of thank yous. Okay, then, great. So this is a time that we want to announce our next webinar. Our next webinar is also on the similar lines of Azure. It's not Azure DevOps, but it's closely related to DevSecOps, about bringing developers and security together by using visual code maps. So we're going to be deep diving into VS Code or some other editors, looking at some add-ons to see how to effectively communicate security vulnerabilities and look at insights of where a vulnerability can traverse from one point to another. We're going to invite some external guests next time from a company called Appland, and more information will follow. Follow our LinkedIn pages and Twitter if you are our followers there, and we will post our next webinar date, schedule, and the content and the speakers shortly. But for today, thank you very much for joining us. It has been a great pleasure delivering this webinar to all of you. I hope most of you found that informative. We will, of course, share this on our YouTube channel sometime later. Until then, take care. And then from Tactical DevSecOps, we'll see y'all later.